Deciding whether a dilation represents a reduction or an enlargement is pretty easy to do. I mean, you guys know what the words reduce and enlarge means. What can be tricky though is figuring out which one it is because the diagrams are sometimes a bit confusing. And so what I want to do with this example, the safety pin and the paperclip, is start by figuring out which image or which figure represents our pre-image, our initial one. I know in this first example that the smaller paperclip represents my pre-image, and it's not because it's first, it's not because it's smaller, it's because the label is just labeled with a single letter like P. Our second figure is going to be the image because I noticed the prime, just like we've dealt with other transformations. So in this case, going from the pre-image to the image, I can see that this is getting bigger, so obviously in that case this is going to represent an enlargement. But again, if we don't know which one's which, it's hard to tell. In our paperclip example, this time I'm going to start the same way, figure out which represents the original figure, the pre-image. Again, check your labels to figure that out. So looking at my label, I can see that the bigger one this time is labeled just with the single variable without any primes. So this time the bigger figure represents my pre-image, and the smaller figure then represents my image. So again, going from the pre-image to the image, I can see that I'm getting smaller, then obviously this is going to represent a reduction. Well, the second part of this is then figuring out what is that scale factor. How much have we enlarged or reduced our figure by? And to do that, we'll use this formula that I've written down in the bottom. We're going to take some measurement of the image and divide it by that corresponding measurement of the pre-image. Now, if you forget to do it in this order and divide the wrong way, I'll show you a way that we can double check that once we get our answer. So let's use, I'm going to just use SF for scale factor. These are fairly easy because there's only two numbers given to us, but again, we have to make sure that two numbers we pick, one of them needs to be from the pre-image, the other one needs to be that corresponding, that matching side from the pre-image. And so in my safety pin example, the image this time was the larger the larger safety pin, and I can see that this 12, the distance from sort of that vanishing point in the background to the image is 12. That corresponding the side that it matches up to for the pre-image is just 8. And again, by corresponding, I mean they match up. There's sort of that center vanishing point to the top of the pin. So I get 12 over 8, which of course is not an okay answer. I always want to simplify fractions. So if I simplify that, I can simplify down to 3 over 2. Or if you'd rather just write these as a decimal, that's okay too. I get an answer of 1.5. Now I told you I'd give you a way to tell if you're right in case you had flipped this around. Because we had originally said this was an enlargement, I know that my scale factor has to be something that's bigger than 1. A number greater than 1 is going to enlarge the figure, and so of course 1.5 is greater than 1. If I had done this incorrectly and set up 8 over 12, I would see that that's going to get me a number smaller than 1, and that wouldn't be an enlargement, so I would know something hopefully went wrong. Okay, if I try the same thing on the second one, knowing that it's a reduction, this time, even before I find it, I'm going to say my scale factor must be something that's less than 1, like a half or a third, for example, something that would shrink it down. So once again, to find that scale factor, I want to find a measurement to the image. This time the image was the smaller figure, so I'm going to take that vanishing point to the image, which was a distance of 18. And I'm going to divide that by its corresponding distance in the larger figure, the pre-image. So in this case, 30. Once again, I'll simplify that fraction. I can simplify that to 3/5, which is of course less than 1, so that checks out. Or if I get a decimal, I can say it's 0.6. So the image is 0.6 times as big as the original, meaning that it has been shrunk down or reduced.